All right, so here we go with some handwritten notes since you don't have the next bit of the handouts. So this is the integral test. All right, if f is positive, continuous, and decreasing for x greater than or equal to 1, and an equals f of n. So in other words, just like we're writing the sequence as the function, okay? Then for the sum of n equals 1 of an and the integral either both converge or both diverge. So again, most of these are not going to tell you what things converge or diverge. Will converge to. They just say that they do. Okay? All right, so let's see. Let's do an example. So we're going to say discuss the convergence / divergence. Number 1. The sum from n equals 1 to infinity. Oh, and this would be an infinity up here too, so they match. Of n over n squared plus 1. Okay, so obviously we're going to use the integral test, but I want you to get used to the first thing you always do before you use the integral, before you do anything else, is do that nth term test. So what's the nth term test? You look at the sequence and you just think. So this is me just thinking about it. You just go n over n squared plus 1 goes to what? Well, it's bottom heavy, so 0. So I'm just going to put that little fluffy cloud there because that's me thinking about it. So unfortunately, it does not fail the nth term test, so I got to keep going. All right, so if f is positive, continuous, and decreasing. All right, so we're going to say, well, let f of x equal x over x squared plus 1. All right, so it's just for x greater than or equal to 1. So that for x greater than or equal to 1. All right, what does this look like? Well, it's definitely positive because x is positive and x squared plus 1, okay? So f is positive. Okay, we don't even need to say anything because we've already said like x is greater than 1 and we know x squared plus 1. I just think that's kind of obvious. Okay, f is positive. All right. It is continuous. Since, remember your domain rules, it's just fractions, logarithms, and even roots, but the denominator can't ever be 0, so because that would be an imaginary number to make that 0, okay? All right, and then we just need to show that it is decreasing. Well, that's actually the nth term test. All right. It is decreasing since the limit as n goes to x goes to infinity, sorry, of x over x squared plus 1 equals 0. right? Since it's positive and it's going to 0, then that's decreasing, right? Also, you could take the derivative if you wanted to and show that it was, what, negative for x greater than 1. But I mean, this is fine. Okay. All right, so then it's decreasing, so now we can actually do the integral test. You have to say those 3 things: positive, continuous, and decreasing for x greater than or equal to 1, and then do that. All right, so and then this is an improper integral, so hopefully you didn't jump ahead and do that. But that equals the limit as b goes to infinity right, and then we're just going to do u sub, right? That is u, so that's 1 over u du, which is the limit as b goes to infinity of 1/2 ln of u from 1 to b. Epsilon of 1, which that's 0. So, okay. So then now what does that go to? B goes to infinity. That is infinity, so it diverges. Okay, so therefore, by integral test, I should say by the integral test, excuse my grammar, the series okay, let's do another one. Okay, the sum from n equals 1 to infinity of 1 over n squared plus 1. All right, so we're going to let f of x equal 1 over x squared plus 1. It is positive, continuous, and decreasing. For x greater than or equal to 1. Okay, so then now we do the limit as b goes to infinity of 1 to b of 1 over x squared plus 1 dx equals the limit as b goes to infinity of, what is that? Oh, that's arctangent. Equals the limit as b goes to infinity of arctangent of b minus arctangent of 1. Arctangent of 1 is pi over 2. No, pi over 4? Yeah. Yeah, where is tangent 1? Pi over 4. Okay, so then that is, what does arctangent go to as it goes to infinity? Well, you take, it's probably helpful to know the graph of arctangent. Well, you just take pi over 2 and negative pi over 2, the asymptotes, the vertical asymptotes, and you flip them sideways, and then it goes like that, where this is 0. Sorry, I know that was a little backwards. But that's it. So What does arctangent go to as you go to infinity? 1. Pi over 2. Think about it. That's like the upper limit of as you go. Let's see. How could I think of that another way? Let y equal arctangent of b. So that would be, or theta. Let's go theta. So then the tangent of theta equals b. So the limit, so infinity, what's the tangent of theta? Yeah, so what's the tangent? So if this is infinity, what's your theta to get you to infinity? Well, if you think of the graph of tangent, it goes whoop right there at pi over 2, right? Because it looks like that. Sorry, it's getting like tiny. But that's just my thought process there, is that, well, if this is infinity, what theta gets me to infinity when you get close to those asymptotes? So that's why it's pi over 2. So pi over 2 minus pi over 4. And that doesn't, this answer doesn't matter. It just matters that you get an answer, right? This is not what this equals, okay? Therefore, by the integral test, just gonna plug that off, okay. The sum of 1 over n squared plus 1 converges, that is the answer. Okay? Alright, sorry. My arm is falling. It just does not. Okay. Continue on. Actually, no, that's it for this one.